Howdy, y'all, and welcome to episode number 35, I believe the number is. We're going to be covering science and how I believe it's become more of a religion than it is what it was intended to be or what it is intended to be. Um, as you can see, I got a couple tabs open here. We're going to go over two kind of key areas, and we're going to watch a video or two of some other folks sort of breaking it down. But let's go ahead and see what Wikipedia has to say. You really can't make a good video if you don't include Wikipedia as your source. So, science is the systemic discipline that builds and organizes knowledge in the form of testable hypotheses and predictions about the universe. And it goes on to say it's broken down in different branches and all that sort of stuff. But one thing that comes to mind when we think about science is we utilize the scientific method, which is actually in that statement as well. So the scientific method is an empirical method for inquiring. I cannot read today. For acquiring knowledge that has been referred to since the 17th century. The scientific method involves careful observation coupled with rigorous skepticism. Very key component there, because cognitive assumptions can distort the interpretation of observation. Scientific inquiry includes creating a testable hypothesis through inductive reasoning. And as we'll find out, it's also inventive reasoning, but the original was inductive reasoning. Testing is through experiments and statistical analysis and adjusting and discarding the hypothesis based on the results. So, what is empirical? Empirical evidence is obtained through the senses, experience, or experimental procedure. It is a central importance to the sciences and plays a role in various other fields. So, what they're trying to say is science and the scientific method. We're supposed to utilize our senses, observe the world around us, make some hypotheses, and then go out and try and prove these things to be true. This is inductive science. Now, what we pretty much have is mostly inventive science, where people will come up with an idea, and then they'll go out and try and prove that idea to be true. And we'll actually watch a 1-minute video where a guy discusses this back in the early 60s. So what is religion? Religion is a range of social cultural systems, including designated behaviors, practices, morals, beliefs, worldviews, texts, and all this sort of thing. So basically, science is supposed to be a way that we observe the world and test how it works. Religion is a set of behaviors and morals that we use to develop, or that we use to formulate how we live our lives. So these two things are very different. One is a formulation to live your life, hopefully in a way that staves off suffering. Science is going out and gathering the tools. It's not a pre-built tool set. And then without any of the morality or the worldviews or this sort of thing, you can use it to construct things that function like bridges and whatnot. So, science is a method for gathering information that can be used as a tool, and religion is a set of social norms and behaviors. So there should be a very clear difference between the two. Now, of course, a tool can be used in the way you live your life. So they do blend together, which is the reason why I do believe science has blended with religion. Because as folks have lost their religious views, they've replaced them with scientific views. And that's sort of my point. And it's quite dangerous. Religion, especially successful religions, they developed over many, many thousands of years. And they've figured out the psychology of a human being. They've made observations of society and which and what forms function well and which do not. If you read the Bible and pay attention closely, you will notice it is actually an observation of human behavior. Well, in one way, it's an observation of human behavior and human psychology and how to correct some of the errors that we make in our behavior so that we can hopefully, well, move on to the next world. But let's go ahead and go on into my couple key evidences or a couple points where I believe you can see that science has definitely fallen into the religious field. So remember, Wikipedia here was saying that it was inductive. It's through observation, empirical acquiring of knowledge. So here we are. This guy is giving a lecture back in 1962 or something.
I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it.
Exactly.
Then we
not empirical, inductive.
Then we compute the consequences of the guess.
Or not inductive, inventive. We invent
see what,
the idea.
if this is right, if this law that we guessed is right, we see what it would imply.
1964.
And then we compare those computation results to nature. Or we say compare to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are, who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.
So, as he pointed out, modern day science is a guess. They make a guess, and then from there, they go out and try and prove that guess to be true, or their hypothesis. This is called inventive reasoning. You invent a thought and then go out and prove it to be true. But he pointed out the key, as long as you can prove it to be true, it's okay that you're using an alternate form, especially if you can prove it to be true empirically, meaning through experiment and observation, especially the observation. Because as we all know, you can lie with math, especially statistical math. Let's see. Let's go. We have to go all the way back to 9 something on this guy. Here we are, 916. My bad. So in this next little video, we're going to cover this guy. He's going to go over 2 scientific constants and how they're probably not very constant. As you can see, he's exposing scientific dogma. And of course, dogma refers to religious beliefs. So he's kind of covering the same thing, but from a different angle than me. Let's go ahead and listen to what he has to say, because I think it's really important that we understand just how far-reaching that this is.
But I want to spend a few moments on the constants of nature too, because these are again assumed to be constant. Things like the gravitational constant, the speed of light, are called the fundamental constants. Are they really constant? Well, when I got interested in this question, I tried to find out. They're given in physics handbooks. Handbooks of physics list the existing fundamental constants, tell you their value. But I wanted to see if they changed, so I got the old volumes of physical handbooks. I went to the Patent Office Library here in London, and they're the only place I could find that kept the old volumes. Normally people throw them away. Speed of light dropped between 1928 and 1945 by about 20 kilometers per second. It's a huge drop because they're given with errors of any fractions of it. It dropped, and they were all getting 48. It went up again. I was very intrigued by this, and I couldn't make sense of it. So I went to see the head of metrology at the National Physical Laboratory in Teddington. Metrology is the science in which people measure constants.
Trying to save you time,
I asked him about this. I said, what do you make of this drop in the speed of light between 1928 and 1945? And he said, oh dear, he said, you've uncovered the most embarrassing episode in the history of our science. So I said, well, could the speed of light have actually dropped? And that would have amazing implications if so. He said, no, of course it couldn't have actually dropped. It's a constant. So, well then how do you explain the fact everyone was finding it going much slower during that period? Is it because they were fudging their results to get what they thought other people should be getting, and the whole thing was just produced in the minds of physicists? We don't like to use the word fudge. I said, well, what do you prefer? He said, well, we prefer to call it intellectual phase locking.
That's funny.
So I said, well, if it was going on then, how can we be so sure it's not going on today? And that the present values are produced by intellectual phase locking. And he said, oh, we know that's not the case. I said, how do we know? He said, well, we've solved the problem. And I said, well, how? He said, well, we fixed the speed of light by definition in 1972. So I said, but it might still change. He said, yes, but we'd never know it because we defined the meter in terms of the speed of light. So the units had changed with it. So he looked very pleased about that. They'd fixed that problem. But I said, well, then what about big G, the gravitational constant known in the trade as big G? It's written with a capital G, Newton's universal gravitational constant. That's varied by more than 1.3% in recent years. And it seems to vary from place to place and from time to time. And he said, oh, well, those are just errors. And unfortunately, there are quite big errors with big G. So I said, well, what if it's really changing? I mean, perhaps it is really changing. And then I looked at how they do it. What happens is they measure it in different labs. They get different values on different days, and then they average them. And then other labs around the world do the same, and they come out usually with a rather different average. And then the International Committee on Metrology meets every 10 years or so and average the ones from labs around the world to come up with the value of big G. But what if G were actually fluctuating?
So here we are. Clearly, dogma has entered the scientific world. We are supposed to be exploring and using solid scientific principles like skepticism and observation to determine how things really work and function. But because humans, what's the word? I really want to add this back in here again. This whole please don't take me so long to find it. Here we are. I'm not going to find it again. But where they're talking about how our cognitive abilities to deceive ourselves. Oh, here we are. Because cognitive assumptions can distort the inherent or the interpretation of observation. So what do? We've already made a cognitive assumption. Speed of light and G are a constant, period, in a story. And so instead of worrying about what we're actually observing in the world or interpreting what we see in the world, never mind, it's a constant. That is not scientific principles, my friends. This is what they refer to as, cognitive assumptions. All right. So I'm going to go over my two little pieces, and one of them is this from 1953, Watson and Crick, Nature. DNA has changed the way we live our lives. But if you read in the very, very first sentence of their paper, they say, we wish to suggest a structure for the salt of deoxyribonucleic acid, DNA. This structure has novel features which are of considerable biological interest. They have a suggestion. You see, I think most people believe that we actually know what DNA looks like. If you go on to Getty Images, we've been fed these things right here for the last 70 years. This is DNA. We all know what DNA is. Kids in first, second grade pointed out. Turns out that isn't really true. The first pictures of DNA and the ones that helped them to write their hypothesis is this. I don't think Most people think this famous photo 51, taken by this lady down here, and all these other photos, this is DNA. It's not what we think of. We all have this in our mind. Now, think about the ramifications in law and medication and some moral areas where we believe that we actually know what this is. But, what we're working with is that old, this is what we had. So I went out and was wondering if there is a newer version, which is this page here. I assumed, since 1953, we had to have gotten a better look at it. This was updated in 2024, but this picture was taken in 2012. So basically, in 60 years, this is the best picture we have of what DNA looks like. Not one person would say that this was DNA if you saw it. Not one person. And then when you read how this image was taken, this is what DNA looks like. This is not what we imagine DNA looking like. And if you read how it was made by this Enzo Di Fabrizio over at the University of Genoa, he developed this whole procedure. They took DNA threads out of a dilute solution, laid them on a bed of nanoscopic silicon pillars, like tying threads on a bed of nails. What does that bed of nails look like? They probably could have made this look like anything if they wanted to. You can't see. Where's the silicon pillars at? They drilled some holes. I think that's what all these little spots are for the electrons to go through so they can get an image of it. But they made this structure, dried this out on it, and say, hey, look, we have DNA. This is supposed to be their proof, which is just staggering when we all believe it's this. And we use this information for, like I said, I'm not going to go into that. You have to think for yourself. Where do you think DNA is affecting your life? Affecting our government? Affecting... how is it affecting where are we going to go religious wise? Is it affecting our behaviors, our cultural system, our morals, our beliefs, our worldview? Does DNA have an effect on any of these things? I'm saying it probably does. Next one. This is a tough one for a lot of folks. And this word, settled enough. Now, I'm not going to go over this whole article. This comes from this courses, whatever, at Harvard. We're just going to scroll down to the bottom and read the last paragraph in a little bit. But what they're talking about is the modeling of climate science and how, maybe it's not perfect, but it is close enough for us to make decisions on how we live our life. Again, science is supposed to be filled with all this scientific method, supposed to be skepticism and all this stuff to make sure that we're not having any cognitive assumptions. But here we are. It's good enough. So we're going to start. We're just going to read from here down. Gotta forgive my terrible reading skills, my friends. Like I said, I really do have a learning disability. It's very difficult for me. So here we are with the Suki Manabe, one of the founding fathers of climate modeling. And then we're going to go over that a little bit. Climate sensitivity, the amount by which the global average temperature increases upon doubling of the amount of carbon dioxide in the atmosphere, is one of the key uncertain factors governing our climate future. And results on this key parameter are almost invariably presented in the terms of distribution of possible values. It's uncertain. We don't know what the real values are going to be, but we'll keep going on. And remember, this is climate modeling. Science is never settled, but it can be settled enough. Newtonian mechanics was not settled science. It was overturned by both relativity and quantum mechanics. Nonetheless, it was and continues to be settled enough to build bridges and design airplanes. Yes, those are empirical. You can use quantum or Newtonian physics and design a bridge, and it works. It's testable, it's provable. This is key. Remember, can you test it? Can you prove it? Can you make an assumption and does it fit your guess? Remember what the guy said. If you have a guess, it's fine starting with a guess as long as your experiments prove out to be true. Not that your experiments prove out to be uncertain and possible values. Yeah, we'll go on. It is in this spirit that the word settled is used sometimes in connection with climate science, and not in the cartoonish sense that the person that they're talking about fabricates in a straw man argument. It is always easy to find gaps, even very significant gaps. So now we have significant gaps along with, what was the word up here? Uncertainty. In the understanding of a system as complex as the climate. But the issue on the table isn't whether our understanding is complete, but whether it's complete enough to justify the need for serious controls of carbon dioxide emissions. It's not the situation that the range of climate predictions runs from pretty good to somewhat bad, meaning we think, it could be good in the future or it might be kind of bad. The truth is more like they believe the range is it could be really bad or it could be bad or it could be extremely bad unless emissions are halted and eventually reversed. So, do we have cognitive assumptions? Are we using skepticism? Ask yourself when these people speak, fully able to say in papers like this, where they're like, yeah, we have serious gaps in our knowledge. We are making wide ranging assumptions. But also look at this. Look at the ranges. The ranges from good to somewhat bad and bad to extremely bad. What did the guy say? If your experiment doesn't prove out to be true, then the whole hypothesis is wrong. It's not science. These guys have 4 outcomes. If you can't prove a singular outcome, it is not science. It's not by definition. And because you're using these things to change the way you live your life, you're changing our behaviors, our morals, our beliefs, our worldviews, and our cultural systems. We're changing these things based on what we think is this and what is wide ranging from good to extremely bad. Knowing that we have big, massive gaps in our knowledge and understanding on how these things work. So here we are on ThoughtCo. See, a model is supposed to be used to construct complex concepts. Basically, what an atom looks like and how we think it moves, the solar system, maybe some medical stuff. But we do use computational models for prediction purposes. So we're going to come to here. So this is a science pod. Understanding Scientific Models, a comprehensive guide. I admit I haven't read this whole thing, but we're going to read the key takeaways. Scientific models are representations of systems that help explain and visualize scientific processes and natural phenomena. All right. Models can take different forms, such as representational, descriptive, spatial, mathematical, and computational models. I believe climate is computational. Yeah, probably. Scientific models have limitations and may not capture all the details or accurately represent reality. We range from pretty good to extremely bad. Models can change over time due to new discoveries and the need for updated and revised information. So, is climate affecting our behavior? Is it affecting our social norms and our moral worldview? Is it solid science? Brings me to one of my favorite. I made a video about this a couple years ago. And this was big news back in the 90s when they built these biospheres, trying to, they're actually doing this to try and basically work out space travel, knowing that you can't bring enough oxygen and food and all that. So you're going to have to actually move a whole biosphere if you're going to try and colonize outside of our system. So these folks were trying to build systems so that we can learn how to do that. So let's go ahead and we're going to listen to two little spots.
And almost right away, things started to go wrong on Biosphere 2.
And one of the first things they began to notice is that oxygen began to go down and down and down. About halfway through this first 2-year mission, it got so low that they had to add oxygen in because they were concerned for the safety of the individuals inside.
This was a problem. The introduction of outside air defeated the purpose of the closed system that Space Biosphere Ventures was trying to achieve. This, along with the perception that management wasn't being forthcoming with their problems, led Biosphere to be losing credibility as fast as it was losing oxygen.
They were very heavily scrutinized by the media and the press, and as they say, the wheels came off the wagon at that time.
Along with the oxygen loss, Biosphere 2 experienced a number of other problems, including massive plant and animal die-offs. The Biospherians had difficulty raising enough food to feed themselves and were constantly hungry. This contributed to morale problems, causing a rift in the group, splitting them into 2 factions, and these problems, along with the abrupt resignation of the project's scientific advisory board, seemed to confirm the view that the biosphere was just for show and not actual science. A second mission was attempted in March of 1994. This second crew was able to fix some of the problems the first crew had, but because of management disputes and dissension among the crew that culminated in 2 Biospherians sabotaging the closed system, the mission ended after only 6 months. Biosphere 2's managing body dissolved at this point, and with its original purpose seemingly invalidated, the fate of the project was uncertain.
Geez, it seems like they failed big time.
A lot of people like to say because of sort of this initial falling out and loss of credibility that it was a failure. And no experiment is a failure. And that's what this was and is it's an experiment on a grand scale, had never been attempted before, and the engineering is absolutely amazing. But what they did learn, and probably, in my opinion, the single most important lesson, is really how little we truly understand Earth systems.
How little we truly understand Earth systems. Again, remember what he said? What does he say? Let's have him say it again.
How smart you are, who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all.
If it disagrees with experiment, it's wrong. We can't even make. Hold on, we'll go over. There's one more small little section right here. Let's see.
Mechanical equipment that sits below us in a basement-like space that we call the technosphere. Biosphere itself, the footprint is a little over 3 acres.
Look at all that.
And you have almost 2 acres in this technosphere space where we have these big units here. These are our workhorses. These are air handlers, so they circulate the air as well as condition it. Up above, we can see all kinds of pipes that are running. So these are going to move water from one location to another, electrical lines, pumps, motors, but it takes all of this to recreate that which Earth is doing every day for us.
In addition,
Think about it. There's a 3-acre space with 2 acres of all that equipment, trying to at least figure out how it works. And we don't know. The experiment failed. So, back to the original point. Has science moved into the world of religion? I'd say just from these 2 examples I gave of how DNA isn't exactly what we think it is. I didn't go into the fact that the number of base pairs has changed radically over time. I mean, don't even go down that. And all sorts of other proofs that we have out there, or evidences, over this really big issue that is affecting so many different things right now. But going back to the very basic principles, what is science? Science is supposed to be this objective view of the world where we gather information. That's it. A method of testing and experimenting to try and get this human need to change the way we see the world. What do they call it? Cognitive something. We lie to ourselves. We're going to try and change information. It's just the way we are. What do they call it? Cognitive assumptions. They distort the information. We see the world one way, but we have these pre-built-in assumptions, and we allow those assumptions to change what we actually see. 10 people can watch one event, and you ask them what happened, you're going to get 10 different answers. We don't see the world the same. Science is supposed to be a method that we use to eliminate that. But when you start using these inventive sciences instead of inductive sciences, where you have a guess and then you build models or you build theories, if the tests don't prove out, you're supposed to throw it out, like the guy said. You have to prove it through the experimentation and observation. And I pointed out 2 points right here. One a little bit as an example of how we think science says something is happening when it's one way, and DNA. We think that we have these clear images of this thing. We know exactly what it is and how it looks and how it functions. We really don't. It was just a suggestion on how it could function. And then we have my second example, where clearly that is being used to formulate policy. And so is the first, just in a much more subtle way. I would say science clearly has stepped into the world of religion. They're using their beliefs to change the way you see the world. They're using their beliefs to change what is morally correct. And as the guy pointed out in that first video, or the second video, where he shows that even the constants, because they fluctuate, and we have this cognitive assumption, it has to be a constant. We would be the ones that are making the error because the world is a constant, because they believe the world is a machine, or the universe is a machine. And because it's a machine, it has to be perfect. So if something like the speed of light changes, of course it doesn't change. It's a machine. We must have made the mistake. Their cognitive assumption is the human beings made the mistake, not the universe. The universe is a perfect machine. Appears to be what they're saying. Same thing with Big G. They make you learn a number, and it turns out it's just an average. It's crazy. So that's going to be it for this video, my friends. Just some food for thought on how if you don't have a solid worldview, eventually you're just going to make one up, which is what we're doing now. The world around us is actively making up a new religion because they killed off the old one. Learn your values, my friends. Figure out what you truly believe. As I've said before, I do this right here because I'm attempting to absolutely, solidly be able to figure out what I believe. I call it the megnosis. But we all must do this for ourselves. So until then, my friends, I will see you on the next one.